Hello everyone and welcome to lab number 6 in this course. Now we are going to start working on the multiple areas in OSPF. So this is the lab that we have to go through. Actually I made it very simple, 4 points, but inside these points you will see a lot of things that we need to do. So here we can see we have more than areas now. We have area 0, that's the backbone, and then we have area 1 and we have area 2 over here. Inside area 0 we have 4 routers, and inside area 1 we have 2 routers because that's also is in area 1, and also in area 2 we have also 2 routers, this one and that one. Okay, now for the RIP, now that's something we do it later. In this lab we're not going to work inside the RIP, okay? That's something we do it when we want to redistribute RIP inside the OSPF. So what we are going to do now is the same what we've been doing before on the single area. We have to configure OSPF on all routers, and now we have to create the areas, and then we have to put the interfaces on of the routers which are on the second areas, and then we have to see how the routing will happen. So we're going to pass through many things, like if the routers, for example, in area 0, the backbone areas will receive the routes which are on area 1 and area 2 and vice versa. Okay, so that's now the simple way to configure the multiple areas in OSPF, and in the upcoming videos I will be doing more and more labs inside the multiple areas. Just to mention here that every of the routers has a bridge interface. So if you want, you can think like router 1 has 11.11.11.11, router 2 has 22.22.22.22, and so forth for all the routers. And that's really can help us when we want to see if they are receiving routes. We can really find it inside the routing table. Okay, so let's now start directly and see what we have to do in this lab. Okay, so here we have the 4 points that we have to go through. Point number 1, all IP addresses are already configured as on the picture, including the bridge interfaces. Okay, so that's something I have already done it. All the IP addresses are already configured, and I tried to ping from one router to another on the connected interfaces, and everything looks okay. Okay, now point number 2, enable OSPF on all routers and on all areas. Put the right router ID on each of the routers. Okay, so let me go first to router 1. And let's see here, we have router 1, it is on Ethernet 1 and Ethernet 3, and it's inside area 0. Okay, so first what we need to do, we go to routing, and then we go to OSPF. Here I will put the routing ID 1.1.1.1, we do it very fast. And router 1 is on area 0, we have area 0 here already configured. Then we have actually, because router 1, all the interfaces on area 0, then I will put network 0.0.0.0/0 on the backbone. So I advertise everything. That's router 1. Router 2, we go to routing, and then OSPF. We have to go first to routing ID 2.2.2.2, and then we have area 0 is already there. Then we go to the network, and then I will publish the interfaces. So we have, let's see that what we have here. We have Ethernet 1 and then Ethernet 2. Okay, so 192.168.12.0/24. That's on area backbone, that's fine. And then we have 192.168.23.0/24. That's also on the backbone area. And we do not have to forget to advertise the bridge interface that we have created. So router 2, everything is on the backbone area. Now we have router 3 is connected to router 2 and to router 5 and to router 7. Okay, so we go to router 3, we go to routing, OSPF. Here we put the router ID 3.3.3.3. And then we have to go to networks, and then here we say 192.168.23.0/24. That's on the backbone, that's between the router 2 and router 3. And also we have 192.168.53.0/24. That's also on area 0, the backbone. And then we have 33.33.33.0/24, also on the backbone. But now we have this interface, Ethernet 3 of router 3 is inside the area 2. Then now we have to configure area 2 and we have to put the network which is connected on Ethernet 3 inside area 2. Okay, so that's the network 192.168.37.0. Now we go again to router 3. That's router 3, we're working here. And then from here you go to areas and then you make plus and you say I want to create area 2, which has an area ID 0.0.0.2 as we have here in the graph. So this area has been created. And now I will advertise 192.168.37.0/24, but instead of saying that I want it to be in the backbone, I just put it in area 2. So now we have all the network advertised inside router 3. Okay, let me now go fast to router 5. Router 5, it has a link on Ethernet 2, which is inside area 0, and then also on Ethernet 1, which is also inside area 0. And then it has Ethernet 3, the link on Ethernet 3, which is inside area 1. Okay, so we have to put 192.168.15 and 53 and the bridge interface in area 0. And then 56 will be inside area 1. Okay, so let's do it. We go now to router 5. Okay, I will go to routing and then from here I go to OSPF. I will put the router ID 5.5.5.5 and then let's put first the networks which are inside area 0. So 192.168, the one which is connected to router 1 is 192.168.15.0/24. That's in the backbone area. And then the one which is connected to router 3 is 53. Okay, so also we go here 192.168.53.0/24 is in the backbone, and we always have to advertise the bridge interface inside the backbone. And then we still have the link which is connected to area 1, which is 56. Okay, that's the one we have to put it in area 1. So we have to create area 1. We go here, areas, area 1, and that's area 1. And then here we go to networks and then 192.168.56.0/24, and I want it to be in area 1. So now we have finished router 5. Let's see what we have still to do. We still have to configure OSPF on router 6 and on router 7. Router 6 is connected to router 5 and it's on area 1, and then we do router 7. So let's do first router 6. We go to routing, OSPF, we just put the router ID, that's for router 6. And then we do not have any interfaces on area, the backbone area, so we need to create area 1. That's for router 6. And then we advertise the network 192.168. should be 56.0, if I'm right. Yes, 56.0/24, and this we put it on area 1. And then we have to advertise the bridge interface /24, and then we put it on area 1. So that's what we need to do on router 6, and we still have router 7 now. It is on area 2. Then we have to first put the instance. Router ID here, we put 7.7.7.7. And then we create the area, so we have to create area 2. And then we put it in area ID 0.0.0.2. And then we advertise the network, which is 192.168.37.0/24. And that's in area 2. And also we advertise the bridge interface that is on this router in area 2. So this way we have already configured OSPF on all our network diagram here using the multiple areas. So we configure the routers which are inside the backbone area and also the routers which are between the backbone and the other areas. And also we have configured the OSPF on the routers which are inside the other areas. Okay, so let's see now what we have to do in the other points. So point number 2, enable OSPF on all routers and on all areas, and we put the right router ID, so that's something we have done. Now, which routers are now the ABR? And then point number 4, can router 6 and router 7 reach the bridge interface of router 1? Now, before we go to point number 3, let's first have a look what we have now. So we have already enabled OSPF on all routers, that's good. we have to go to routing, and then we have to go to OSPF. Let's see first if we have neighborship. We see now that router 1 is forming neighborship with router 2 and router 5, which should be okay. So router 1 should form neighborship with router 2 and router 5. That's good. And then if we look to the LSA here, okay, we can see that router 1 is getting LSAs from all the routers, and you can see here the LSA types. We have network, we have router, we have summary. So there are different LSA types in OSPF. Okay, let me first explain to you about the types in OSPF. You have different types. We will see many of them. We are now seeing 3. So the first type, which is the router. Okay, router, we call it type number 1. And normally it is sent by the routers which are within the area, and it's including the list of directly attached links. Okay, that means that each router inside the area itself will send it to the other router, and that's what is the type of this one. So it's always within the area. Now the second type we have, it's the network type. The network type is mostly happens on the transit networks. For example, like if you have a multi-access. Okay, for example, if we have a DR and like in a multi-access or in broadcast network, the DR is the one who sends the network type. So the type number 1 and type number 2 happens inside or within the area itself. The third type is the summary network. The summary network is advertised by the ABR. In our case over here, if we look here, we have router 5 and router 3 are the ABR. So the router 5, which has the full topology overview of the 2 areas here that he is connected to, then this ABR will advertise the routes from one area to another by type number 3, which is the summary network. And if you look here, we can see that's 77.77.77.0, which is the bridge of router 7 over here. Okay, so it's over here. It is advertised by the router 3 as a summary network to now router 1. We are working on router 1. Okay, so these are now the 3 LSA types, and we can see them over here. So this is what I wanted to show you here, the LSA. And then here we can see the routes that is learned from the OSPF on router 1. Then router 1 now, he knows, of course, he knows his bridge interface. He knows how to reach to router 2 from OSPF. He knows how to reach to router 3. So this is the bridge interface, router 5, router 6, and router 7. Okay, you see 6 and 7, both of them, they are on other areas, but router 1 can reach them because at the end, the OSPF is one autonomous system. It's inside our company, then we can reach to the networks which are on the other areas. Now, if we look to IP routes here, and we go to the routes here, then we have really what is inside our routing table on router 1. So router 1 can reach now. You see the O, that's OSPF, and all those networks are learned by router 1 from OSPF. Okay, so this is what I wanted to show you over here. So now we know what are the LSA types, and we've seen that the ABR is the one who can provide the routes from one area to another. All right, now let's see what we have here. Which routers are now the ABR? Okay, I'm on router 1 still. If I go inside the area border routers over here, router 1 directly defined that the routers which are 3 and 5, you can see here the router IDs of the routers, are the ABR, the area border routers. Okay, we can look inside here if you want. You can see that this is the router 5. Okay, and those 2 routers are the ABR, router 3 and router 5. So let's look now in router 3, which is the ABR we said, and then we go to routing, we go to OSPF. If we look to LSA, that's what I wanted to see here. As you can see over here now, router 3, because he's the ABR, he has overview about the backbone area, because if you look in this graph, router 3 is connected to the backbone area over here, and is connected to the area 2 over here on this interface. That means he is the ABR, and as we can see here, you can see area backbones with the type of LSAs over here, but also you can see the area 2, and that's on router 7. Okay, so here if you look to the routes, you can see that he has backbone and area 2. Okay, so router 3 is the ABR. Another thing that I want to mention about also, if we go now to router 1 and we go to routing OSPF, And then we go to route over here. You can see here that the routes here that is learned from OSPF, okay? Here is intra, 1, 2, 3, intra, and here is inter area, okay? So what's the difference between intra and inter area? Any route which is learned from OSPF within the area that this router is in, which is the backbone area, so this is called an intra area because it's it's inside. And any route which is learned from the other areas is called inter area. For example, if we see here the 66.66.66.0, that's the network of the bridge interface of router 6. Router 6, if we look again inside the graph here, we see it that it is in area 1. You can see it over here. So that's in area 1. So the bridge interface that is learned from this router is an inter area because this area is not the same as where router 1 is sitting in area 0. That's why it's inter area. While if we take another one, for example, this one, for router 2, the bridge interface or the network where the bridge interface belongs to, which is 22.22.22.0, that's intra area because router 2 again is inside area 0, then it's intra area. Okay, so that's the difference between intra area and inter area as for the route. All right, let's now see what we have to do more in this lab. We've seen which one are the ABRs. And now, can router 6 and router 7 reach the bridge interface of router 1? Let me go first to router 6. And I can just open a command line and I say ping 11.11.11.11. And directly we can see we have a ping. Same if we do on router 7. That's router 7 now. And I go here and I say ping 11.11.11.11. And also I have a reply. And that's because router 6 and router 7, they have learned from OSPF. We go to IP routes here. They have learned from OSPF how to reach 11.11.11.0. So this is what I wanted to show you in this lab. We have seen many things. We have configured the multiple areas. We have seen what are the ABRs and what are the LSA types and how the ABR advertise the networks. And also we have seen the difference between the intra area and the inter area inside the route of the OSPF. And then we have made a small experiment to see if router 6 and router 7, which are routers outside the backbone area, if they can reach the bridge interface of router 1, and we've seen they can do that. So this is what I wanted to show you in this lab. I hope it was informative for you, and I'll see you in the upcoming lecture.